So, come on. Marana. Right, hang on. Huh?
I know, it's unbelievable.
It's before 12 o'clock and it's raining and you're here. Shouldn't you be like asleep now or something? What?
Yes.
Right. Now, what we're going to look at is finding the angle between two vectors. Just before we do that, I have to give you a definition of how to multiply two vectors together. So, if we have this vector here, x1, y1, z1, and if we want to multiply it, and the type of multiplication, it's called a dot product, also called a scalar product. I usually call it dot product. So if we want to dot multiply,
Is this a new lesson?
no, this is an old lesson. You've travelled back in time. Yes, this is a new lesson.
What's the
Let's say dot product and angles. Okay, so the definition of the dot product is as follows. You multiply the I components plus the j components plus the k components. Now what you'll notice is the result is not a vector. The result is a number. So for example, the vector 1, 2, 2 dot 1, 0, 1 would equal 1 plus 0 plus 2, which would equal 3. So that's really important. This dot product doesn't give you a vector, it gives you a number. There is another type of multiplication which we do not do, which does give you a vector, which is called a cross product. But we just do the dot product. And the reason for the dot product is it'll be very useful in calculating angles between vectors, which we'll do now. So that's just an example of a dot product. Yes? Also, maybe it's worth pointing out that I dot I equals j dot j equals k dot k. They're all equal to 1. So for example, 1, 0, 0 dot 1, 0, 0 equals 1. Or for example, 0, 1, 0 dot 0, 1, 0, that will equal 1 as well, so on. But then when you have them mixed, so if you only had an I and dotted with only a j, so what would that be? That would be 1, 0, 0 dot 0, 1, 0. What would that equal? 0. So when you have two basis vectors which differ, their dot will be 0. And if they're the same, their dot will be 1. Not very important, but it's worth pointing out. Already now? And the only reason is I feel sad because you were looking hungry and pathetic. So just don't make a mess, okay? Right?
Okay. Can we as well?
I'm sorry, you don't look hungry and pathetic. She does. Yeah, no, take it as a compliment. Yeah, you don't look hungry or pathetic. Yeah. It's funny because it's true. Right, okay, now next, why is this so important? Because it will help us calculate the angle. So let's look at trying to find the angle between two vectors. So all you need from that is the definition, really. The definition up the top. Okay. So let's see if we can get a formula here for the angle between two vectors. So there is O, and then there is A, so that is vector A. And then there is O, and there is B, and there is vector B. And we want this angle here, theta. So So we know A, so let me call A x1, y1, z1. And we know B, let me call it x2, y2, z2. And we'd like the angle between these two vectors. Now, even if this is in 3 dimensions, it still makes a triangle. So if you had 2 vectors, doesn't matter what way they're pointing, in 3 dimensions, you can always connect the ends of them and you can get a nice flat triangle every time. So I will fill in red the extra information we can work out, which is this line here. That's the vector AB. Now, AB, what will that be? Not A plus B? B minus A. So that would be x2 minus x1, y2 minus y1, z2 minus z1. Yep. Good old AB is B minus A rule. Hasn't changed. Okay. Now, if you think about this as a triangle, we are given A, we are given B, and we can easily get AB. Meaning, we know the 3 vectors representing the 3 sides of this triangle. Therefore, we can know the 3 lengths. Length A, length B, length AB. Triangle, 3 sides. How can we find the angle of one of the sides? By using what rule from semester 1 trigonometry? Cosine rule, very good. So you can say that AB squared equals A squared plus B squared minus twice A, B, cos theta. And we are looking for a formula for the cos theta. So a little bit of rearranging gives me cos theta will equal that one squared plus that one squared all over, no hang on, minus that one squared all over minus, so plus now 2. I've done a couple of things in my head here. I took this over to the left and then took the AB one over to the right. No, don't do this. I'm picturing a big question mark popping over your heads now. I took this one over to the left and swapped it with that one. So I have this, this, and this on the right. See? There, there, and there. And then, now this is on the left, and I divide it by this piece here. So now it's underneath. I would, at this stage in your lives, I shouldn't be showing you every single algebra line step. So trust me, you can rearrange it in step. Does anybody feel strongly that I've made a mistake? Brendan, get off the phone. What?
I'm just researching the dot product rule.
But I'm teaching you it right now.
Because we did something like I know.
Later, please. Like, this is what I hear. This isn't good enough for me. Nuts to that. Right, that's how I got the cos theta. I'm pretty sure I did that okay in my head. Take it across, divide it down. Yeah. So now we have to simplify the top. You remember the formula for magnitude? It is square root x squared plus y squared plus z squared. Yeah? But because this is squared, that's great because it will get rid of the square root. So you're just left with here x1 squared plus x2 squared, y1 squared plus z1 squared. And then what about the b? That would be x2 squared plus y2 squared plus z2 squared, and then minus the AB here. So I'll have to make a bit more space. Let me zoom out. So that would be minus, now what was the, x2 minus x1, okay. x2 minus x1 squared minus y2 minus y1 squared minus z2 minus z1 squared all over 2a times magnitude A times magnitude B. Yeah? Which I'll just leave for the moment. I don't want to put too much on one line. So I'll leave it like magnitudes. But of course you know it's square root x1 squared plus y1 squared plus z1 squared. Anyways, we can open these brackets. But if I open this bracket, what would be the very first term? x2 squared. And you see, look, you got an x2 squared there. And for example, if I open this one here, what would you get? y2 squared with a minus. And so on, you get z2 squared. So a lot of things cancel on the top. So let's see what cancels. So when I open this up, I get a minus x2 squared. So that one's gone. And then I get a minus, so let me put it in here. I'd get a 2, x1, x2. And then at the back, I'd get a plus x1 squared. But I have a minus here, so I'd get a minus x1 squared, which cancels that one there.
So then technically all of them should...
So the same thing will happen for the other two here, and on the top you'll be left with this. But what's in common to everything? 2. And does the top line look familiar? x1, x2 plus y1, y2 plus z1, z2. What is it? It's the dot product. So on the top it becomes a dot b, and on the bottom you get magnitude A, magnitude B. If you really wanted to, you could go one step further. What if you have a vector A and you divide by, don't worry, I'll go back to this on the left. If you have a vector A and you divide it by its magnitude, what have you done to the vector? You've made it a what? Last class, or maybe 2 classes ago? Yeah, with the hat, what's this called? Unit vector. So you could actually write it like this, A hat dot B hat. But that's not usually how it's done, but it's worth pointing out, so it's just a side note. Anyways, we have our result. You can say cos the angle between the vectors will equal A dot B divided by magnitude of A times magnitude of B. And these are all vectors. Or another way to write it, a much shorter way if you wanted to, or it's A hat dot B hat. So this is the main result. Now, even with this result here, there's a very important corollary, follow-up result. If the vectors are perpendicular, what is the value of theta? No, theta, if they're perpendicular. The angle, 90. And what's cos of 90? 0. Yeah? You can't, of course, divide by 0. So the only way to make this fraction here 0 is if the top is 0. And that's a very, very important result because it's very simple, but it provides a quick way to check if vectors are perpendicular. So if A is perpendicular to B, you must have A dot B equal to 0, and vice versa. So in other words, if I give you vector A and vector B and I ask you, are they perpendicular? A very quick way to check if they're perpendicular is by checking if their dot product is 0 or not. So as a small quick example, 1, 2, 3, 4, 1, 1. I can tell straight away that these are not perpendicular because their dot product would be 4 plus 2 plus 3, which is not 0. So I know definitely they're not perpendicular. Now, what about this one? 1, 0, 0 and 0, 0, 1. What's their dot product here? 0. So they are perpendicular. But of course they are, because what's the first vector here? It's I. And what's the second vector? K. So we knew already that they were perpendicular. But I'm showing you the dot product provides a very, very, very quick check if two vectors are perpendicular. So it's very useful in that way. And I think in that book I gave you there, the exam book with the questions, you don't have it with you? No. This came up in section A. You know, very short question. Here is vector A, here's vector B. Question, are they perpendicular? So, you know, quite short. And another thing we'll do now is we'll, as an example, calculate the angle between two vectors. So, question? So the first example I gave you there, are they perpendicular? The answer is no. So let's calculate the angle between these vectors. Yes? Look up. So I'll take this one as an example. So what's the formula? Let me go to the right. Do you have this one written down, these numbers? Yeah? Okay. So to calculate the angle between them, cos theta equals A dot B, which is 4 plus 2 plus 3, which is 9, divided by the length of A and the length of B. Okay, what's the length here? That'd be square root 1 plus 4 plus 9. So that's square root 14, I think. And then what about the other one? 16 plus 1, that's 18. So now, by typing this in on your calculator, you can get out what the angle is. Can somebody tell me, please?
Sorry, how did you get it?
Which numbers? This whole thing here? I use this formula on this example. So this is like my A and this is like my B. So the top is A dot B and the denominator is the length of A multiplied the length of B.
So that is formula, right?
So just cos inverse this fraction. What do you get, Precious? Do you have it? Did you get the fraction? Yeah. Yeah. 55.5. I'll do another one.
I'm sorry, is the 114 multiplied by the...
Yeah, that's a multiply here.
I got 0.56.
Good, and then do cos inverse of that. Yeah. It's okay. Yes? Okay. Do you need another angle example? I don't think so, really. Yes? Okay. Right, so first one, you need to write that down? This part? Okay. Yep, okay. Right, another example. So I want the angle between this one and this one here. What's the angle between them, those two? So cos theta equals dot on the top, 3 plus 2 plus 2 over square root 1 plus 4 plus 4 square root 9 plus 1 plus 1. So if you want theta equals cos inverse 7 over 3 root 11. So what's that going to be, please?
$45.3.
45.3 degrees. You got that? Yes? Okay. All right. Another example. Okay. Or an angle of 45. So here I give you two vectors and I tell you they make an angle of 45 degrees. Tell me what the missing number is here. So you could probably figure this out. You use the rule again, except this time you know the angle. So you write in cos 45 will equal the dot. So what's the dot here? What would it be? X plus 4 minus 3 all over square root x squared plus 1 plus 9, and then the other one square root 1 plus 16 plus 1. Now cos 45 I know is 1 over root 2 equals x 4 minus 3 1. This will be square root x squared plus 10, and this will be square root 18. So I should definitely take that over to here. Square root 18 divided by square root 2 is 3. Isn't it? Yeah. Root 18 divided by root 2 is 3. Think about it.
Sorry, how did you get the root 2?
How did I get the root 2? Hold on, slow down, one at a time. How did I get what? Wait, slow down. Yeah, cos 45, yeah.
It's root 2 over 2.
Root 2 over 2 is the same thing as 1 over root 2. Look.
Okay, I understand.
Do you? 1 over root 2, and then you multiply above and below by the conjugate. So it's the same thing. Slide back. Oh, there we go. Alright. Any other questions then? How did I get 18? This here is 3. Isn't it? Yeah? Somebody tell me how it's 3.
18 by 2 is
It's
9.
root 9, so
Yep. So 3 equals x plus 1 over square root x squared plus 10. Now you definitely don't like the square root there, so easiest way to get rid of the square root is by squaring. So let's square everything. 9 equals x squared plus 2x plus 1 all over x squared plus 10. I square everything.
sorry, is that 18 or 100?
Yeah, sorry, got messed up there. It's an 18. Bring the denominator up to the left. 9x squared plus 90 equals x squared plus 2x plus 1. So you get 8x squared minus 2x plus 89 equals 0. So mode 53, please. Give me the two answers here. Well, I sure hope there should be two answers. I don't think it would be impossible to make these angles not at 45 degrees. They don't have an answer? No. 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 Bastard. Of all the vectors I could have chosen, I picked two that couldn't possibly be at 45 degrees. Alright. Well, we'll just pretend it had an answer. So x equals something and something. Yeah, so actually, I know what I'll do. We can just go back to the question, and then I could say, show that there is no value of x that could make them at 45 degrees. There you go. Well, of course, in the exam, they would definitely give you vectors that could be made to be at 45 degrees. That's disappointing. Oh well. I should have stayed in 2 dimension. It's easier to picture them. Okay, one last small thing to do. This type here, it's more common that they ask you for the angle between the vectors. They don't usually ask you the reverse. They don't usually tell you the angle and ask for the vector, although they could. It's more typical that in the exam they give you the vectors and they ask for the angle. Yep. Okay. One last example. Importance of dot product. So here is vector x, which is 3i plus 4j, and then here is vector y, which is 5i and 12j. Well, that's totally not to scale. And my question is, I have another vector here. Let's call it vector just 1, 1. And I would like you to write 1, 1 as multiples of x and y. So in other words, I want you to write 1, 1 as so many x's plus so many y's. So what am I doing? Well, it's like I'm changing the base. It's like instead of using i's and j's, I'm using vector x and vector y. Because remember we said before that you only need 2 vectors to describe everything in 2 dimensions. So the question here is, what is the lambda and what is the mu? So you get 1, 1 equals mu x plus lambda y like this. So you get 1, 1 equals 3 mu, or actually, yeah, 3 mu plus 5 lambda all over 4 mu plus 12 lambda. Now if you think about it, what does that look like? Well, it looks a bit like what we did in semester 1. You know, 3 mu plus 5 lambda equals 1, and then 4 mu plus 12 lambda equals 1. We all know how to solve this. So you could find the lambda and mu this way. Whatever it is, I won't bother solving it. I was going to think, do I want to show you it? Alright, I know I did tell you the last time that I'd show you how to use the dot product to do this, but it's not actually on the exam and I was just going to do it for fun. But you don't look like you're in a fun mood today, so we won't do it then. So you can just do it this way. Gives the calculator there, I'll get the lambda and the mu is. So if you solve that, you'll get lambda equals 7 over 16 and mu equals minus 1 over 16. So you get the result vector 1, 1 is equal to 7, oh wait, sorry, that's the other way around. Mu is this one, lambda is this one. Lambda is on my x, yeah. Mu is on my x, okay. So you get 7 over 16 x vectors minus 1 over 16 y vectors. You want? I just solved it. You can use elimination substitution matrix method. Does look strange. So you could say your vector 1, 1 is equal to about half a vector x minus about a 16th, well, a 16th vector y. So what you're doing is you're writing your vector 1, 1 as so many x's and so many y's. The technique to finding the lambda and the mu is not important. You can use whatever method you like. They won't say in the exam, use blank to find lambda and mu. They'll never say that. So I think this is probably the easiest way to do it because it's most similar to what you did in semester 1. So that is quite common in the exam. It is quite common for them to ask you to find the numbers in front of vectors, the lambda and the mu. So if you look back, I gave you the x, I gave you the y, and I asked you to write 1, 1 in terms of x and y. That would be, a very likely, maybe not a section A question, but a part of a section B question. Okay. You got that taken down? Yeah.
Did you give us the sheet for magnitude and direction?
I did not? No. I've been using the book on Google for vectors. It's very good, actually. There was a sheet.
Yeah.
Oh, that's just for me.
Could you please post it in one?
Really? This was just more. Really? Just because I made it doesn't mean it's good. You want it? All right. Okay, let me just stop it there. So